Okay, just to quickly make a video about this problem 3 here, that's on page 100. You have this combination of birdseed mixtures, A, B, and C. You want the blend of the minimum cost, that's 20% thistle and 30% corn. Given this data, determine the percentage of mixtures. So your variables are the amounts of A, B, and C. These have to add up to 100%, or they could add up to 1 if you're using proportions. And then this gives the data for A, B, and C. So these two give you your constraint, and this gives you your objective function. Right? So if we set this up, we'll get a system something like this. At the top, so these are the amounts, A, B, and C. Oops, B and C. All right, so they add up to 100%. Then these are the percentage constraints. I've kind of switched this around. I've added the, because I made it a less than or equal to, and then I added this slack variable here, a slack variable here. Okay. The right-hand side has to be positive, so I changed the signs around. I do want to minimize this quantity, which was the cost. All right, then we add the accessory variables in order to get a basic feasible solution. So we add the F, G, and H, and then this is the original optimization function, but we treat it as a constraint. And then here's the new constraint, minimize F plus G plus H. All right. Now it's not in canonical form because my basic variables are F, G, and H, but my so this is, I shouldn't say, this isn't, it's not really a constraint, it's accessory optimization function. Okay, so in the original problem, I'll treat this as a constraint, as if it was a constraint, and I'll treat this as my optimization. As I'm sure you've seen by now, the way you treat the constraints and the optimization function really is no different. You still do the same operations on both. So when I did this in the session, my mistake was I didn't change this into canonical form because the optimization function should not have the basic variables in. So you take these three equations that have the three basic variables and you subtract them from this equation F plus G plus H. And here I can just say this is equal to W. Okay. All right. So I need to subtract these three equations from this minimization equation. Now if I do that, from this equation I have plus F that will subtract from this F, plus G subtract from this G, plus H will subtract from this H. So on my left-hand side I'll have no more F, G, and H, and I'll only have the non-basic variables. Okay. So that's what I do here. Now here I forgot something here. This one should be plus D plus E. Forgot to do those. But I get this equation simply by subtracting these three equations from this equation on the left-hand side and on the right-hand side. Okay, I don't have to worry about this one, just the first three. All right. And that will get rid of my basic variables. So this one here becomes my new optimization function. Okay. So now I have my canonical form. To create canonical form. And then Ram shared how the canonical form would look. Let me see if I can get that over here. No, it's not this one. Let me go on WhatsApp here. If I can copy this. Can I copy the image? Let's see if it works. Let me see if I can paste it here. Okay, here we are. All right, so what's going on here? Let me see if I can use my highlighter. Highlighters here. Okay, all right. So you can see we have here this is the original minimization function. And then these are the three constraints. And then this one is the new optimization function. So you can do it this way. Like I said, it doesn't really matter if you put this new optimization function first or later. Now this one here we really didn't need, right? This last one is just a duplicate of the earlier ones, so you really didn't need this one. That's the same as the first one. All right, so now what do you do? This is really my optimization function. So I'm looking at this row, and I pivot according to this row. The most negative entry is this one here. Okay. So that should determine my pivot. Okay. So what I want to do is I want to look at the three ratios up here and see which one is the smallest. So my three ratios are, let's see if I can type. Can I type? Probably not. All right, so I'll try to draw. So the first ratio, this is 100 over 1. Well, we can just do this by hand. This is 100 over 1. This is 20 over 0.25, which is 80. This is 30 over 0.4, which is 75. So I'll need to pivot on this one here. So my new pivot, the place I'm going to pivot is this one here. I'm going to pivot on this one here, the 0.4. Okay, and then you can see that's what he did because this became a 1. All right. Now your new objective function, again, you don't need that last line. The last line is a duplicate with the first. Okay, so we don't need that. So we're actually looking at our objective function down here. So the most negative entry is this one here, the minus 0.631. All right, so we're going to look in this column to see where we pivot. All right, and be careful, this is the x3 column. So x3 column, and then so we have to look at the ratios here. So we would have here, for the first one, let me just see if I can do this. Can I type over here? So my ratios are, the first one is going to be 25 over 0.625. That's my first column. Second one is going to be 1.25 over 0.006. Okay, that looks pretty big. And then the last one is going to be, here's my x3, 0.375. Sorry, this is so small. Maybe I can actually make this bigger. Okay, yeah, that should be more helpful. Okay, all right, and then the last one, so this was 1.25 over 0.406. This one here is 75 over 0.375. All right, and again, I don't want to look at this one. I just want to look at these three here. So 75 over 0.375. 75 over 0.375. Okay. All right, so it's pretty clear that the first one is the smallest. So we'll have to go ahead and pivot on the first one. So that's this one here, the 0.625. So this is my new pivot right here. Well, I should make this another color. So anyway, so the new pivot is here. Okay, so you would click on that and pivot, and you can see that's where he did because here it is right here. It turned into a 1. All right. So at this point, what do I have? I have I have my new objective function here. This is positive, this negative. Okay, so I'll have to pivot on this row here. Okay, so I'm going to pivot there. So let me do that one. I'm going to pivot here. Okay, and let's see. So here I have to check the ratios here. If I can do that, I'm going to have to go small again. Let's see. Here, let's do this. Yeah, then maybe I can fit it over here. So I'll make this a little bit smaller. Whoops. All right. Okay. All right, so I have to be careful to do this. It's x5s. So the ratios here are what? Ratios here are, so I'm looking at the x5 column. So this is 40 over 4 is the first one. Okay. The second one is going to be, there's my x5. That's a point. That's 1 over 0.6. And then this one is negative, so that's disallowed. So it looks like we have to pivot on this guy here, this 0.6. So I'll make that another color. Looks like I have to pivot on the 0.6, right? Okay, because that's my... So let's see if that's what we got. And here he did pivot there, so we have this. Okay. Right. Now at this point, lo and behold, we get this. We get this here, which is what we want. Our basic solution has x6, x7, x8 is 0, and then I have x3 equals 33.3, and x5 equals 1.667, x1 equals 66.67. All right, so that's going to give me my basic solution. And from this, I can, after this, I can simply remove the last two and go ahead with this. So at this point, I can simply remove that last row because I don't need this anymore. And like I said, we don't ever need this row here because that's just a duplicate of your... And then this also I don't need. Right. So that's actually a good way to set it up. I wasn't thinking about this, but here if you leave your original constraint up here, and you put your new constraint, your accessory variables constraint, as the last equation here. Then once you've gotten this in the form, and you have your this equation completely in terms of accessory variables, then you can just drop off this equation and continue on with these equations here. Okay? So I hope you can follow that a little bit better, and my apologies for messing up during the session tonight.